In today's video, we will learn about piecewise function. So these are things to understand. At the end of the lesson, you are expected to illustrate piecewise function. Second, evaluate a piecewise function. Third, graph a piecewise function. Fourth, identify the domain and the range of the piecewise function. And lastly, solve problems involving piecewise function. So first is piecewise function and its definition. So a piecewise function or a compound function is a function defined by the multiple subfunctions, where each subfunction applies to a certain interval of the main domain. So illustration, the absolute value function f of x equals absolute value of x can be written as piecewise function. F of x equals x if x is greater than or equal to 0, negative x if x is less than to 0. So the definition of piecewise function, it contains multiple subfunctions. So in this case, we have two subfunctions, f of x equals x and f of x equals negative x. So as a whole, it can be called as a piecewise function. So in illustrating this piecewise function, so we have the graph of the first subfunction, the second subfunction, and we will combine it into one. Okay, so that is a piecewise function. So evaluating a piecewise function. Given the piecewise function, identify in which interval the value of x belongs. Second, substitute the value of x in the given subfunction. So for example, we have the function or the piecewise function f of x equals negative 1 if x is less than 1 and x plus 2 if x is greater than 1. So f of x equals 1 and f of x equals x plus 2 are the subfunction of this piecewise function. Next, x less than 1 and x greater than 1 are the intervals. So we need to evaluate f of 2. So in evaluating this one, we need to look at the interval. So since we need to evaluate 2 to the piecewise function, we need to choose in the two subfunctions where 2 does belong. Is 2 less than 1? So it is not. If 2 is greater than 1, yes. So therefore, we will be using the second subfunction to evaluate 2. So we will be using f of 2 equals x plus 2. The second subfunction is equal to input 2. So 2 plus 2 equals 4. So therefore, f of 2 equals 4. Next. So here we have a piecewise function with three different subfunctions. So f of x equals x minus 3, 2x, and 2x plus 1. So negative x is less than negative 1, x is equal to negative 1, and x is greater than negative 1. So we need to find f of negative 5. So negative 5 is less than negative 1. So therefore, we will be using the first subfunction. So evaluate f of negative 5 equals x minus 3 is equal to negative 5 minus 3 is negative 8. So therefore, f of negative 5 is negative 8. Next, f of negative 1. So in this problem, we need to evaluate f of negative 1. So negative 1 is obviously equal to negative 1. So therefore, we will be using the second subfunction, which is f of x equals 2x. So f of negative 1 is equal to 2x equal to 2 times negative 1 equals negative 2. So therefore, the answer is f of negative 1 is equal to negative 2. So next, f of 2. So 2 is greater than negative 1. So we will be using the third subfunction. Evaluate f of 2 equals 2x plus 1 is equal to 2 times 2 plus 1 equals 5. So therefore, f of 2 is equal to 5.